Welcome to the Fact Addict. Today, we're diving deep into one of the most mind-bending events in the universe. What happens when two black holes collide? It's a cosmic dance of unimaginable forces, where the very fabric of space and time is torn apart. But what does it mean for the universe? And what can we learn from these cataclysmic events? Black holes are among the most mysterious and powerful objects in the universe. Formed from the remnants of massive stars that have collapsed under their own gravity, these regions of space have gravitational pulls so strong that not even light can escape. But what happens when two of these titanic forces of nature meet in the vast expanse of space? Black holes are born from the death of massive stars. When these stars exhaust their nuclear fuel, they collapse under their own gravity, creating a singularity, a point of infinite density surrounded by an event horizon, the point of no return. One of the most groundbreaking discoveries in recent years has been the detection of gravitational waves, ripples in the fabric of space-time caused by the acceleration of massive objects, such as the collision of black holes. These waves were first predicted by Einstein's theory of general relativity, but it wasn't until 2015 that scientists finally detected them. In September 2015, the Laser Interferometer Gravitational Wave Observatory, or LIGO, detected gravitational waves for the first time. The source, a collision between two black holes over 1 billion light-years away. This discovery opened up a new way of observing the universe, allowing us to hear the cosmos in addition to seeing. But how do black holes collide? It all starts when two black holes are in a binary system, orbiting each other over millions or even billions of years. As they spiral closer together, they lose energy in the form of gravitational waves, eventually leading to a collision and the formation of a new, larger black hole. As these black holes orbit each other, their immense gravitational forces distort the space around them, creating spirals of energy. When they finally collide, the event releases an enormous burst of energy in the form of gravitational waves, shaking the very fabric of the universe. The collision of two black holes is one of the most violent events in the universe. The resulting black hole is more massive than the sum of its parts, as some of the mass is converted into energy and radiated away as gravitational waves. But what happens inside the black hole? That's a question that continues to baffle scientists. Once the black holes merge, a new event horizon forms, marking the boundary beyond which nothing can escape. Inside this boundary lies the singularity, where the laws of physics as we know them break down. What exactly happens inside a black hole remains one of the greatest mysteries of modern science. The detection of gravitational waves from black hole collisions provides us with a wealth of information about the masses, spins, and distances of these black holes. But more than that, it gives us a glimpse into the most extreme conditions in the universe, conditions that we could never replicate on Earth. While black holes are often thought of as cosmic vacuum cleaners, their collisions can have a significant impact on their surroundings. The massive energy release can heat up surrounding gas and dust, potentially triggering new star formation or altering the dynamics of entire galaxies. In some cases, the collision of black holes may also produce electromagnetic signals such as gamma-ray bursts or X-ray flares. These signals, combined with gravitational waves, could provide a more complete picture of these cosmic events. But detecting them remains a challenge. Black hole collisions may play a key role in the evolution of galaxies. Supermassive black holes, which reside at the centers of most galaxies, may have grown through a series of mergers with other black holes. Understanding these collisions could shed light on how galaxies themselves evolve over time. The detection of gravitational waves is just the beginning. As technology advances, we'll be able to detect more frequent and distant collisions, providing us with a deeper understanding of the universe. What will we discover next? The possibilities are endless. Could a black hole collision ever pose a threat to Earth? The short answer is no. The black holes detected by LIGO are millions or billions of light years away, far beyond the reach of their gravitational influence. But the thought of such powerful events occurring in our universe is enough to inspire awe and wonder. Black holes are also at the frontier of quantum mechanics, the branch of physics that deals with the behavior of particles at the smallest scales. The collision of black holes presents a unique opportunity to study the interaction between quantum mechanics and general relativity, two of the most fundamental theories in physics. Primordial black holes, if they exist, are thought to have formed in the early universe, shortly after the Big Bang. If these black holes collide, they could produce gravitational waves with a distinct signature, offering clues about the conditions of the early universe. While LIGO has detected the collision of stellar mass black holes, supermassive black holes, which are millions or billions of times more massive than the Sun, could also collide. These events would produce gravitational waves with much lower frequencies, detectable by future space-based observatories. Could black hole collisions be linked to dark matter, the mysterious substance that makes up most of the matter in the universe? Some theories suggest that dark matter could influence the behavior of black holes, or even be composed of primordial black holes themselves. The collision of black holes doesn't just distort space, it also affects time. In the vicinity of a black hole, time slows down due to the extreme gravitational forces. What would it be like to witness such an event up close? The reality is beyond our comprehension. Every black hole collision leaves a lasting legacy in the universe. The resulting gravitational waves ripple outward, carrying with them the history of these cosmic events. Even after the black holes have merged, their influence continues to be felt across the cosmos. As we continue to study black holes and their collisions, we may uncover new and unexpected phenomena that challenge our current understanding of physics. What mysteries remain hidden within these dark giants? The journey of discovery has only just begun. By studying black hole collisions, we gain insight into the history of the universe itself. These events, some of which occurred billions of years ago, provide a window into the conditions of the early universe and the processes that shape the cosmos we see today. Black holes have captured the public's imagination like few other astronomical objects. The idea of these invisible, all-consuming entities colliding in the depths of space is both terrifying and awe-inspiring. What do you find most fascinating about black holes? Share your thoughts. The discovery of gravitational waves was made possible by the collaboration of scientists from around the world. As we continue to explore the cosmos, international cooperation will be key to unlocking the secrets of black hole collisions and other cosmic phenomena. What could the future hold for black hole research? Some scientists speculate that studying these cosmic giants could lead to advances in our understanding of gravity, quantum mechanics, and even the nature of reality itself. The implications are profound. Could there be black holes lurking in our own galaxy? While most of the black holes detected so far are located in distant galaxies, there are likely many more hidden within the Milky Way. Finding them could reveal new insights into the history and structure of our galaxy. Imagine being able to detect a black hole collision in real time as it happens. With advancements in technology and observatories, this possibility is becoming more realistic. How would it feel to witness such an event unfolding before our eyes? As we continue to explore the cosmos, black holes will remain a key focus of scientific research. What new discoveries will we make in the coming decades? How will our understanding of these enigmatic objects evolve? The future is full of possibilities. The collision of black holes is one of the most powerful and mysterious events in the universe. As we continue to study these cosmic giants, we'll gain new insights into the nature of reality, the evolution of galaxies, and the fundamental forces that shape our universe. The search for knowledge continues, and the journey is just beginning. Thank you for watching The Fact Addict. Stay curious and keep exploring the mysteries of the cosmos. Thanks for watching The Fact Addict. Stay tuned for more cosmic mysteries.